Hello everyone, my name is Tarun and I'm an engineer at Dragonfly DB. So as you all know, Dragonfly outperforms the most popular in-memory store by huge difference, right? Be it throughput, latencies, all of that. It has a tendency to do much better than like the existing tools out there, and this is clearly one of the reasons why you choose Dragonfly over other tools. So now, when you choose the Dragonfly operator 2, the expectation is the same, right? You're expecting a similar kind of experience even on like a Kubernetes environment. And considering that with all the levels of abstractions that like Kubernetes has, right, both in terms of like network where you can reach a pod through any node, and also the fact that like all your applications are just run through a containerization platform like Docker-D, Containerd, or any of those out there. So now let's see how the kind of performance difference that you would see on a Dragonfly operator. The gist is that you'd get very similar experience with some slight difference, but it is definitely worth it. So now let's create an EKS the cluster, right? In this demo, we'll start with an EKS cluster, uh, which has a VM type of the C6GN 8x large, right? This is the same instance type that we all use for high performance systems. Essentially, this is the C6GN 8x large, which gives you 30 cores and 64 GB of RAM. We'll try to use all of those in this demo. So here we are creating an EKS cluster in the US East 1 region with the default node group. After this, we'll create two follow-up node groups for both the uh, Dragonfly node group, which we use the C6GN 8x large machine, and then the Memtire node group for the Memtire client here, which will load test the Dragonfly instance. As you can see here, we have the EKS cluster now created and is ready. As you can see, there are the default node groups also present so that we can run the Prometheus packages and also the Dragonfly operator, more importantly. So now let's run those commands to actually run those things. Let's now install kubeprometheus package, essentially, which allows us to monitor all the pods, collect metrics, etc. The resources are now being created. Now it's all done. Now let's install the operator itself, right? Which is the most important part. I think there is one more kubeprometheus package left. Let's also apply that first. And then this is part of the same kubeprometheus installation. Once that is done, we'll next install the operator. So now we have the kubeprometheus package installed. As you can see, it's not just Prometheus operator, all the Grafana, even the config maps to visualize the cluster. So it's all a single package. Now let's install the operator itself, right? And the command to do that is the same. Once we do that, we are essentially installing the Dragonfly operator, which helps us create Dragonfly instances. That should take some time. Now that even the Dragonfly operator is installed, let's now create the node groups for Dragonfly. So essentially, as we discussed, we'll first start with the C6 GN 8x large instance type, which essentially gives us an instance type to install Dragonfly, and then we'll move to Memtire. So let's run the command to get a C6 one instance of that, essentially, because we only need one. We only plan to run one Dragonfly instance on this. So now the node group is getting created. So we now have the managed node group created called the DF. Now let's install Dragonfly onto this node, right? We want to make sure that it is specifically scheduled on this node. So for that, we have slightly different command essentially than the plain Dragonfly instance. Essentially, with additional affinity that essentially schedules the pod onto this node, onto the Dragonfly instance onto this node. So we are asking for a replica of 1 with CPU 30 and the memory limits from 50 to 64. So once we do that, we should have a Dragonfly instance created and placed on this specific node. Yep, it is created. Now let's see if all our pods are created and are ready. So as you can see, even the Dragonfly sample 0 is running. And every other thing is also seem to be good. So now let's create the node type for the Memtire benchmark, right? We'll slightly take a bigger instance type here so that we can run multiple commands, but that is not necessary. Before we actually do that, let's install some debug data, right, on this instance. So let's run the command to add data onto this instance, onto this Dragonfly instance. So as you can see, even the data is added. Now let's run let's create the Memtire node group, right? We'll take a slightly bigger one, like we discussed. Now let's create the memtire node group, which is a slightly bigger instance, so that we can run bigger client runs, but nothing unique here. This should create a memtire node group of 16x large, 116x large machine. We have the memtire node group created. Let's now attach the memtire pod onto this node, right? So we create the memtire pod and then attach that onto this. The command for that is essentially, yep. So as you can see, it's called the memtire benchmark, and it essentially has a node affinity to be scheduled onto this node group. So now if we do watch kubectl get pods, everything should be green. Even the memtire benchmark is now running, but it's just a pod with sleep infinity, right? There's no load test happening right away. So before we run the load test, let's also create a new terminal instance so that we can port forward the Grafana service, right? So that we can actually visualize when the load test is actually happening. So once we do this, if we open Grafana and login, admin, skip. Once it loads, we should be able to go to Kubernetes, compute resources and pod, and actually start seeing data for what has been requested and what has been used, right? So here we are looking at the CPU usage data, and you can see here the limit is set at 30 as we pass. And if we see here, we can also see the memory utilization. The same requests and limits are applicable here too. And the other metrics like bandwidth of the pod, all of that. So now let's actually run the benchmark, right? And now that we have a visualization layer here, let's take the last 5 minutes also. Yeah, so let us now run the benchmarks and see how it's working. So let's go back to our terminal window here and run the memtire command into the memtire pod, right? So essentially we are passing the Dragonfly sample default DNS name along with 24 threads and 20 clients, right? So essentially because we have like more the threads is essentially a match on the CPU, the number of CPU count. So we are first starting with 24 CPUs with 20 clients multiplexed across these 24 CPUs. Now let's run the command, and as you can see here, the test time is 300 seconds. So we'll be running that benchmark for 300 seconds, and then we'll see the value. Now we should see some values popping up. So as you can see here, we are close to 13 lakhs 8,000 ops per second, which is pretty good, and also the latencies are pretty good with a throughput of close to 400 MB per second, which are excellent values. So we are achieving like more than 1.3 million QPS here without doing anything, right? We haven't optimized the cluster, we haven't done anything. So this is to show that you can expect the same Dragonfly performance even on Kubernetes. The same reason why you choose a Dragonfly, you should have no questions on also using it on Kubernetes through the Dragonfly operator or something like that. Let's also look at the Grafana dashboard, right? Meanwhile, because we should see memory being shot up. Yep. So as you can see here, if you take the last 5 minutes, the memory has, the CPU usage has like grown spectacularly. I think we'll close to be 30 cores here because we have given 30 cores, which is the limit also. And even the memory side, the bandwidth also seems to have increased. And on the memory side, we are fairly constant because we are not adding new data. It depends on the key size that is selected. And once the demo completes, we should be able to see the final values here. Let's also take a look at the memtire pod, right, which is actually passing the load. Let us switch to the memtire pod here. And even here, as you can see, there's a growth in its own like core usage, etc. The memory, the metrics take a bit time to catch up. It takes a bit of a time to collect and also showcase into Grafana. So as you can see here, like the CPU usage of Dragonfly shot up because it's Kubernetes, and we have like a 32 core machine, right? Dragonfly can like go more than 30, the limit, which it kind of went, but I think it will go back again. And once the benchmark completes, you should see that the memory usage should just drop after that. Same with memtire. As you can see here, we are at 15. And memory usage is still the same. And the bandwidth, we are close to, the received bandwidth is close to 500 MB per second, and the transmission is at 100. And on the benchmark, we're still doing similar results. And we are at the 75% mark here. And this should complete in the next minute. And as you can see here, we have the whole benchmark has been completed, and the memo and the CPU usage is back to normal. Yeah, close to zero, because there are no operations being done. And these are the final results. As you can see here, we are able to reach 13 lakh 2,094 ops per second on a C6 GN 8x large. We can also do a describe on that once. So if you see, the Dragonfly sample is running on this node. And if you do kubectl describe node, you should see that it's a C6 GN 8x large machine from AWS. Yeah, as you can see here. To conclude, we get similar performance here, right? We are able to reach 1.3 million ops per second. The latencies are pretty good. Our P99 is 0.5 and our P99 point is 0.6 milliseconds, which is awesome if you ask me. And then on the throughput side, we were able to get close to 377 MB per second, which is also great. So the same awesome Dragonfly metrics that you expect and love on Kubernetes 2 now. Thank you.